Good evening. I am often asked, occasionally asked, somebody asked me once, whether I could do my own carbon copy of that flagship BBC programme, The Sky at Night. And the answer is, of course, for legal reasons, no. However, I can do my own version, which we will call Look Up in the Sky. That was better, I think, actually. Tonight we are looking at Venus. Venus is a planet in our solar system. It's the next one in towards the sun from us, and it's really easy to spot in the night sky. All you have to do is look west after sunset, say half an hour after sunset, and it up about 40 or so degrees. You're looking for a bright star. It's the first one that will come out, the first one you'll see. In fact, it's the brightest thing in the night sky after the moon. So as long as you're not looking at the moon, that will be Venus. So with your eyes you can see it, and with a telescope you can see a little bit more. You can start to see the disk of Venus. And what's interesting with Venus, of course, is because it's closer to the sun than we are, it will move from behind the sun, around, and between us and the sun, and back round the other side. So what that means is kind of like the moon, where we have the phases, you see phases on Venus. So it will move between the sort of disc shape into a half moon type look, into a real thin crescent. And what we can do is we can track this over the course of a couple of months. You can sort of watch it, its phase shrink, but also its apparent size grow, because of course remember Venus is moving towards us all this time. So as it's moving towards us, like this, here's Venus, woo, coming towards you, it looks like it's getting bigger. So it's growing, but its phase is shrinking. It's looking more and more like a crescent. Tonight I'll be imaging with a specialist filter, because I'm hoping to tease out some detail in Venus's atmosphere. Venus is covered in a thick layer of cloud. In visible light, the cloud appears fairly bland. However, at the near ultraviolet end of the spectrum, a certain amount of contrast in the cloud tops can be seen. So, I just screw the filter over this monochrome video camera and pop it into the focuser. So the reason we use a video camera to capture loads and loads of frames is because Earth's atmosphere gets in our way. When we're trying to look really closely at stuff, and we do that for the planets or the craters of the moon, we really zoom in because they appear quite small from our point of view. Earth's atmosphere is kind of like looking through a heat haze. Everything's rippling and shimmering. And that's very annoying, and this is why we have space telescopes, obviously, to get above that and away from things, and also why obviously a lot of the Earth-based observatories are on the top of mountains. Thinner atmosphere, you're not looking through so much, also no clouds and things like that. Anyway, I digress. We need to find a way of eliminating all that shimmer. So what we do is we record a video, and a computer program later on looks at that video, finds all the sharp frames, keeps those, and throws away all the blurry frames, so that you're able to stack and create a sharper image often than you can actually see through the eyepiece. It's quite amazing. And you'll experience this shimmer from our atmosphere yourself. All you have to do is go and look at the stars on a clear night, and they're all twinkling. They're not twinkling, obviously, it's our atmosphere that's just shimmering around. And it's very annoying, but yes, this is how we get around it. I've captured my video now. I captured about 7,000 frames, of which I'll probably only keep anywhere between 3,000 to 5,000 of them, and the computer program will do all the clever stacking, put them all together, and hopefully we'll end up with a sharp image, something that, as I say, is maybe even sharper than what you see through the eyepiece, because you're averaging out all of that blurring effect that we get from our atmosphere. So next step is processing. It's freezing. The processing stage involves aligning and then stacking, which is all done by a free program called Registax. After this, I then put it in Photoshop for a tiny bit of sharpening, and then you're done. Well, thank you very much for watching. Do tune in again next time, but for now, good night.